So last week, who else doesn't have notes here? Okay. Last week we learned the weird system of matrix multiplication. Okay, quick review of the weird system of matrix multiplication. Hold on, just quickly update attendance here. The weird system of matrix multiplication meant that if, first of all, matrices are rows times columns. So if I took a 2 by 2 and multiplied it by a 2 by 1, my answer would be the size of the outside one, which would be a 2 by 1. So now I have two spaces that I need to figure out. I need to figure out this space, and I need to figure out this space. In order to do matrix multiplication, the first space in this new matrix represents row 1, column 1. And the second one is row 2, column 1. So to find the answer for the first one, I would take row 1 and column 1. I imagine taking row 1, turning it on its side, and ramming it into this one. The 1 would multiply by the 1, the 2 would multiply by the 2. Add up the pieces, 1 plus 4, and this answer will be 5. Then I take row 2 and column 1 again. And this time I take the 3, 4, turn it on its side. The 3 rams into the 1. The 4 rams into the 2. 3 times 1 is 3, 4 times 2 is 8. Add them together, and this will be 11. And it's a very weird matrix multiplication, because it's like, why would we want to do that? And we're going to try to answer that question today when we do applications. For those of you that are missing, I did post the videos just today from last week. So here's what we do. We take a system of information and we create a matrix. So here is the Burgess Sports Company. It supplies balls, bats, and gloves to different sporting goods stores. And we've got a little bit of the information here. Store P wants 70 balls, 30 bats, and 22 gloves. Store Q wants 60 balls, 20 bats, and 19 gloves. And store R, blah, blah, blah. So we have all of this information. Basically what we're going to do is we're going to imagine a set of square brackets around this whole thing, and that's going to be my matrix. My matrix is going to be, how many rows do I have? 4 rows, 3 columns of 4 by 3. And one of the things that we're actually going to do with these matrices is use the letters for what they stand for. And this will be very important in understanding how we can apply matrix multiplication. So, write the total order as a matrix. So I put those numbers in their spots, and then I also on the outside added my labels. P, Q, R, and S, and I wish the balls were called like spears so we could use the letter S instead of like, you know, bat. Maybe I had to do B-A-L here, is maybe what I did. It's like, you can't even use an acronym, you almost spell the whole word before the letter is different. Man. Should have had sold spears, bats, and gloves. Okay. So that's the total order. I have something under here? It's 4 by 3. Well, this, I think you're going to find this cool. Okay? Like, all of these things you could do, but we're showing you how matrices might make this easier, especially if we can put things into our calculator. Because I showed you how you can enter this matrix into your calculator last week as well. Okay, part B. Write the cost per item as a column matrix and label it B. Well, the balls cost $8, the bats cost $30, the gloves cost $75, So again, I put the balls, bats, gloves off the side here, and the cost up here. It happens to be a 3x1 matrix. And what I'd like you to do, while we're setting this up, I would like you to type this matrix A into your calculator as matrix A, and matrix B into your calculator as matrix B. So I'm going to go second matrix, I'm going to go edit matrix A, and my new matrix is, my new matrix A is a 4x3, so I can go 4x3. And it's okay that the numbers are still there. I'm going to just type over top of them. 70, 30, 22, 60, 20, 70, 54. So I've entered all those values into matrix A. And then I want to enter these numbers into matrix B. So I'll go back to my calculator. And I'll go to matrix again. Second matrix. Edit B. And B was a 3x1. And the costs were 830 and 75. Perfect. And now we've got matrix A and matrix B. Using matrix multiplication, create a matrix C depicting the total cost per store. Now, absolutely, I'm just going to go back here to this slide, right? If I gave you this information, even in grade 8, you would have figured it out, right? How much does store P go to owe me? Well, store P, they buy 70 balls, that's $8 each. You can figure out how much that is. And then what do you have to do? They have 30 bats times $30 each, figure out that total, and then they bought 22 gloves at $75 each, and you would add those all up and tell me how much, and it would not be hard, okay? But now that we have matrix multiplication, something cool is going to happen. Here is our matrix A and our matrix B. It's very important that we do A times B, because A was a 3x3 and B was a 3x1. But not only does it matter that the two numbers are the same in the middle, they also have to represent the same thing in the same order. And notice, for store P, if I turn this on its side and ram it in, won't I get the 70 times 8, the 30 times 30, and the 22 times 75? And what does matrix multiplication do? It automatically adds them up. And what is the size of my answer? The size of my answer is going to be a 4x1, and the 4 stood for PQRS, and the 1 stood for cost. Boom. I've got an answer right away. As soon as I do A times B, I get the total cost for each store with one push of a button on my calculator. Because now I can just go to my calculator and go second matrix, A times second matrix, B. And we get all those totals all added up right away. And as long as we've set things up so the middle numbers match and are the same things, then whatever's on our outside will be what we figured out. Cost for store B, cost for store Q, cost. And it's like, oh, that's really cool that I can figure out a whole bunch of data quickly without having to do them all separately. So you want a matrix D, which includes a 2% shipping charge. Oh, some things you could do. We just figured this out. This was supposedly matrix C. We can hit our store button and store it as matrix C. Then if you want to add 2% to something, everything would get multiplied by 0.02. So I could go 0.02 times matrix C. Oh, this is per item. Yeah, sorry, I did the total cost with the shipping charge.
Can you stay on part B a little bit longer? Oh, no, I meant part C, sorry.
Let me know when you're done, Jeff. And then you need to see this one for a bit more too then?
Yes.
So per item, now the cost is increased. So when we want to increase everything by a certain percentage, that's a scalar multiplication, a number in front, because that would multiply each item by that in that matrix.
JR?
Yeah.
For the equation that says D equals 1.02 times C, but on the other one.
It's B, right?
Yeah.
Yeah, thank you. Let's go up. Let's make the B in purple. Looks like a bed. Bed starts with B. So crazy. Who's sleeping in the bed? Whatever. Not happy with that stick person. Look more dead than Ed. Good? Jeff, good? Okay. So what is the total amount owed by each store? Well, we could take A times D now, because D is now the cost with the shipping in there, and get the total amount. Or you could have taken the total amount we had before and multiplied it by 1.02. That's what I did on my calculator. Got the same numbers there. Yes.
So you have like two matrices,
Mm-hmm.
A and B, and you can like the order you multiply them doesn't matter because it just works.
Okay. But in a word problem, you have to make sure that the items' ideas make sense and match up. So this.
So if you did it the other way, but mathematically it works.
Mathematically it works. You would get a bunch of numbers that make no sense in real life whatsoever. So you could do it, but you just get results that would be exactly the same as if you asked a 2-year-old to tell you 7 random numbers. And you'd be like, okay, this is my answer. I'm going to hand that in. And that will happen. You have to be careful with it. Especially when you have square matrices, because you could totally change how you put things together. And two people could answer the same question, and their setup would look completely different just because how they decided to write their first matrix. I mean, the way this one was written, it was pretty obvious to do it. Like sometimes I even cheat and just like, you know, being the typical lazy math student. Right? Put a big breath. No. Right there, I just answered part one. Didn't want to rewrite anything. Right? Typical lazy math student not wanting to write too much stuff. And then would I ever, right, in question, would I ever do this? No, I would just write A times B. Because that's way quicker than writing all of this down. But with that said, there will always be someone in class who's like, oh, I decided to make the balls, then the gloves, then the bats here, and totally rearrange the numbers, which is perfectly fine. You could do that. And then I'm kind of anti-alphabet right now, so I'm going to go QTRS. And I could put those numbers, and I could rearrange all the numbers, and as long as I made my next matrix also in that order, the multiplication would work. But if I move one thing in order that doesn't match up, then the multiplication means absolutely nothing, and none of your answers or numbers will be right. Just from a marking perspective, please don't do that. It's like, oh, I have to check all your numbers in new places, that's a pain. And then the total amount, well, you could just add up everything. If you wanted to do it with a matrix, this is, how big? This is a 4 by 1. If I want my answer to be a 1 by 1, what could I put here? A 1 by 4. What do you think you would want in that 1 by 4 so that when it turned and crashed into those numbers and added them up, it just did the same thing as adding these 4 numbers up? Okay. All ones. And then they would all add up, and you get the total. Now, personally, I don't think I'd spend the time making a matrix. I'd probably just add them up. It might be. Who knows? Maybe retyping them all, maybe it is quicker to make the 1 by 1 matrix and get your total, right? Okay. So here, another word problem with a bunch of information. A virus hits the school. Nurse Bertha discovers that students are either sick, well, or carriers of the virus. She finds the following percentages of people in grade 11 and grade 12. I don't know how Nurse Bertha figured all this out, but that's amazing. She finds out that in grade 11, only 15% are well, 35% are sick, but 50% are carrying the disease, just waiting to spread it. It's a terrible disease. It's spread by helping others. Now people are scared to help other people now. It's not good. So we've got this data. And then we've got student population distributed this way. There's 104 males in grade 11, 80 females in grade 11, 107 males in grade 12, and 103 males in grade 12. Okay. How many males are sick? I guarantee you could figure this out with this data, right? 35% of grade 11s are sick, so 35% of those are sick. Well, we're making a little bit of an assumption that the percentages are spread out evenly. But what we're going to do is we're going to set up a matrix. And if I set up the well, sick carrier with grade 11s and 12s, and again, I would probably set it up just like the chart is, because it makes it easy. And then males and females just with the chart is. The important thing here is that if I do this, matrix multiplication works, and this 2 of matrix A and this 2 of matrix B, the rows of matrix A match up with the columns of matrix B, and they represent the same thing in the same order. And if you type this into your calculator, trust me, you'll get those numbers. But now, we can answer these questions so quickly, right? How many males are sick? 79. We've now got a new matrix that tells us all of that information. How many females are well? 38. How many carriers are female? 76. Now, the most annoying questions are the ones where they don't give you the data in charts. So you can't like just quickly cheat and make the matrix from the chart. Or even more annoying, they give you the charts, but they give the numbers so they don't match up. So you have to rearrange. Everybody done on this page? Almost, yes? So, again, oops. Oh, I can just scroll down. Everybody get all the numbers from the data? Okay. This is the not fun question. They give you all of the data just in a huge written paragraph. A sound company produces stereos. Their inventory includes 4 models: the budget, the economy, the executive, and the presidential. The budget model has 50 transistors, 30 capacitors, 7 connectors, and 3 diodes. And then it goes and tells you what every one has. This is a lot of data. This is where matrices make your life easy, is when you have a lot of data and just want to organize it in a simple way. Right? Like if you read this, you could answer this question. But it would be kind of annoying, because it seems like you've got way more information. How many transistors are needed each day? How many capacitors, connectors, diodes? Well, how do we do this? First of all, we decide to set up our matrix. And we have transistors, capacitors, connectors, and diodes, budget, economy, executive, and presidential. So you set up a chart of this data. Put the numbers in. Okay? Now, because I made my matrix this way, with the beep down the side, right? I have to make sure I make my matrix with how many I make each day with a beep along the top. Does that make sense? And I can't put the beep along the top on the left-hand side, because then the beeps won't match up. Someone's going to listen to this and think there's a lot of swearing in this video. Right? So I get a 1 by 4 by a 4 by 4. This 4 was a beep. Sorry. And this 4 is also a beep. Do it properly there. And then the 1 is per day. And this form was the TCCD. There. Perfect. Again, we put that into our calculator because it finds us our answer of everything that we need. Transistors per day, 2,810. Capacitors per day, 1,656. So this weird matrix multiplication where it rotated something, crashed into something else, added it all up, we now can see a real life example of where we can use that and how it can be used. And it's kind of like, oh, this is kind of useful and kind of helpful in this situation.
Sorry for the interruption. Would the owner of the jet license plate HO4311 please come to the office? That's the owner of the car with the jet license plate HO4311. Please come to the office.
All right. Not a problem. Yeah. So again, I don't think these questions are necessarily difficult. It's just maybe a little bit annoying to put all the data into a matrix, but it actually makes holding the material and working with it really quite nice and easy. And then you can do all sorts of like, oh, what if we did this? What if we wanted to increase by 40%? Well, you would just take 1.4, because that would add 40% to our original amount, which was B, and my original amount was listed as a row matrix, and we get new answers. And I don't mind the decimals here because I think in a company, if you got 0.8 of a thing done at the end of the day and you had to shut the machines down and then start them up the next day, probably they could continue on from there. All good? All right. So now we add some more complicated. Takes 5 person hours. So 5 people would take only 1 hour together, I guess, if they worked. But it'll take 5 hours total, however many people you have working together on something, to produce the budget model, and so on. So what we have now is we have the hours that it takes to produce each one, or we could write it this way. It all depends what we want to use this for. So how many employees do I need? This is not quite right. Sorry. August and September, we just figured that out here. Per day should be this. I'm gonna copy that and just paste it. Oops. No, it did not paste what I wanted it to paste, did it? Sorry. Just a little frustration. This is what I wanted for. So these are two ways that I could set up, and I wanted to know how many hours per day. Which of these two matrices, this one or this one, should I multiply by this one? Because this one is a 1 by 4, and my beep is here. If I'm going to multiply, does it make sense that I would need to have this one? And I would need to put it behind here, because this one is a 4 by 1 with the beep there. Does that make sense? So you could make your matrix either like this or like this, but you have to decide, what do I want to use it for? Where do I need to multiply it by? Then when I take this and multiply it there, you should get this answer of 249 hours. 7 hours per day, you'd probably have to hire 36 employees for that month. Because in order to do that production, you need 249 hours of work. Each employee works 7 hours a day. So you figure out your employees according to that. So on that handout that I gave you, there's some word problems. You don't have to hand them in. It's just for you to practice as many or as few as you want.